Everybody in today's lecture. In today's lecture, we will going to learn how to calculate the distance, the angles and the projections in R. So first we will calculate the distance between two vectors u and v, and the distance between these two vectors is the norm of the difference of these two vectors, that is usual distance in Euclidean plane. The angle theta between the vectors u and v is defined as cos theta, as u, the dot product of u and v divided by the norm of these two vectors. The last one is the projection. The projection of a vector u onto a non-zero vector v is the vector denoted and defined by projection of u and v, that is u dot v by the square of the norm of v multiplied by the vector. So we will going to solve in this lecture the example 1.5. So in order to do that, we have to first define two vectors. One is u, another is v. So u is 1 minus 2 3, u is equal to 1 minus 2 3, and v is equal to 2 4 5. V is equal to 2 4 5. So u is equal to 1 minus 2 3 and v is equal to 2 4 5. Now we will create a function called distance, which will calculate the distance between two vectors. So we will name that function as distance, and that is equals to a function definition, and that is the body of that function. So the input to the distance function is the two vectors, that is vec1 and vec2. So vec1 and vec2. Okay. So according to the theory, what we have to do, we will subtract individual items from the vectors, square it, and then sum it, and then take a square root of that summation. So first we have to calculate the difference between the two vectors. So the difference is difference dot vec will be, so first we have to check what is the function to calculate the difference of the individual elements of two vectors. Say for example u minus v will be this, and first we have to take the difference and then square it. So this is the difference, and then we have to square. So difference is u minus v, so the difference is this, and the square, so individual, we have to get the square of individual element. So now the difference dot square will be difference square, so difference square will be 136 and 4, and then we sum it. So sum dot difference dot square will be sum of all the elements of that vector, sum dot difference dot square. So sum dot difference dot square is 41, and then we have to calculate the square root of that. So the square root of that is root over 41. So that is correct. So we have to do it inside a function. So it will be vec1 minus vec2. As I already stated in previous lectures, that the arithmetic operators can be used in vectors also, like scalars. So difference dot vec dot square will be difference dot vec and then the usual cat, this is the 2, and then we have to sum it up. That is equals to sum dot difference dot vec dot square. So in order to make us understand in future, I am writing the variables name a little bit elaborate. You can ignore that. You can have your own variable names according to your suits. So it will be sum of difference dot vec dot square, and then we have to square root it. So the distance will be square root function. Under that we have to write sum dot sum dot difference dot vec dot square, and then we have to return dist. So in order to execute this function, first we have to load the source. So this is under D, and then R files and then functions.r. So it is loaded. Now we can calculate dist equal to distance of two vectors u and v, and dist will be this. So if we want to know the answer of 41, this is same, so that is the correct function. Next we will calculate the cos theta, or where the theta is the angle between u and v. So first we need three things. One is the dot product of these two, the square of norm of one vector, and square of norm of the second vector. So in order to do that, so this will be theta maybe cos theta, or maybe just the angle is equal to function So we need two function, one is two parameters, one is vec1 and another is vec2. So first we need the dot of this, so dot product is equals to, so first we have to check how to get the dot product. In the second lecture I have shown you how to get the dot product using some external package, but here I want to do it using my own code. So dot product will be the multiplication of individual elements and then sum it up. So sum of all the elements of a vector, and what is the elements of that vector is the multiplication of individual elements of two vectors. So it will be u multiplication of v, sorry, this will be vec2 and this will be vec1. So this will give the dot product of the two vectors. Next we need the norm of any vector, so that is here. So norm dot vec1 will be norm of vec1 and norm of vec2 is equals to norm of vec2. Next we have to divide the dot product in the next we have to square it. So next we have to square it. Norm dot square dot vec1 is equals to norm dot vec1 and then square. Next we just copy paste it. So it will be vec2, all will be same instead of these two. Next we have to divide it, so the angle dot cos is equals to dot product and then divided by okay, we don't need the square, we only need the norm, so we don't need these two, so it will be dot product by norm dot vec1 into norm dot vec2. During projection we will need the square, so now we will return angle dot cos. Again we have to load it and then we get the angle between two vectors as angle u and v. So the angle will be this. So this is the angle 9 by root 14 into root 45. So 9 by root 14 into root 45. So 0.35, 9 by 0.35. So this is root 14, root 45, u dot v. So u dot v equals to sum of u into v. So u dot v equals to 9. So what is wrong is dot product. Okay, so I have to give a bracket here so that the multiplication is done first, because it is getting the preference here, operator preference. Next we have to load the source again, and again we have to call the angle function, and this is it. This angle is same. Next we will calculate the projection. So projection is equals to a function and in projection we need a dot product and the square of vec2. So it will be vec1 and vec2. So the dot product first will be same as above, sum of vec1 into vec2, and then we divide it equals to dot product divide by the norm square of vec2. So norm of vec2 is same as above, norm of vec2, and then the square of it. So it will be norm dot vec2 square. So this will give the division, and then we have to multiply this with the vector v. So the proj vector will be diff into vec2, and we have to return proj. So now you have to load it again, and then we have to call projection vector is projection, and then two vector u and v. So the projected vector will be 0 0.4, 0 0.8, 1, 0 0.4, and then 0 0.8, this is 0 0.8 and 1. So that is same with the answer. So in this lecture we have learned how to calculate the projection, angle and distance of two vectors using R. Thank you.